Hi, I'm Amy. Let's talk about limits and why direct substitution is the first technique you should always try. When you're working on evaluating a limit in calculus, the very first thing you should try all the time is direct substitution. What that means is take the x value in question and plug it in. If you get a numeric value, if you get a number, that means you're done, you found your limit. If you didn't, well, I've got other videos on how to handle those more complicated situations. But let's look at direct substitution. The problem I have in question here says the limit as x approaches 2 of the function x plus 3. What is that asking? It's saying where's the graph of x plus 3 heading as x gets closer and closer to 2? Okay, well, we know x plus 3 is a line, y equals x plus 3. So all we have to do is take that x and replace it with a 2. We're directly substituting a 2 in for the x. So x plus 3 becomes 2 plus 3, and of course that's 5. If we look at the graph here, here's the function y equals x plus 3. Here's my graph. Here's 2. I'm thinking about what happens as the x values get closer and closer to 2 from each side. Where is the graph heading? Well, we have a continuous graph here, so from this side, the left, and from this side, the right. Both sides are heading towards the output value of 5. So as x gets closer and closer to 2 from each side, the f of x value gets closer and closer to 5. That is our limit. That is where the graph is heading from both sides. So you don't need a ton of practice on these types of problems. I have a couple examples here below that are pretty simple, but I'll walk through them anyway just to make sure it's crystal clear. The first problem says, where is this parabola, this function x squared minus 2x plus 5? Where is it going? Where's the graph heading when x gets closer and closer to 4? Let's try plugging 4 in. So we do 4 squared minus 2 times 4 plus 5. And of course that is going to give us 16 minus 8 plus 5, which is 13. What that tells us is when x gets closer and closer to 4, in fact when x is 4, the output value on that parabola is 13. Next problem, what happens to this rational function as x gets closer and closer to negative 3? So we plug in negative 3 plus 2, and we plug in negative 3 plus 6, and we get negative 1 over 3. So this function, as x gets closer and closer to negative 3, the output value becomes negative 1/3. Last two problems just happen to be trig problems, same idea. Limit as x gets closer and closer to pi for cosine x. Well, what is cosine of pi? That's negative 1. Well, boom, we have an answer. No more complicated than that. What is the limit as x approaches pi over 4 of tangent x? That's just tangent of pi over 4, which we know is positive 1. So again, you get a numeric value, you found your limit. If you don't get a numeric value, you need to try some other strategies. I've got a limits flowchart and lots of other videos to help you figure out those strategies.